Hello everyone. In this tutorial, we are going to solve some of the linear algebra questions that are asked in the GATE exam in the previous year. So let's start. Okay, its first question. Question says that the rank of the m cross n matrix, where m is less than n, cannot be more than. Okay, so they are asking about the rank of the matrix. So uh, let's suppose. Sorry. Let's suppose this represent our matrix possess dimension as m cross n. Now there we know that the rank of any matrix, it's basically represent the minimum number of rows or column which are linearly independent. Okay, so we have to choose the minimum out of number of rows or column which are linearly independent. So here the rank of the matrix uh, must be less than or equal to minimum of its number of rows or columns. Out of these two, or whatever may be minimum value, we have to select this one, not a larger value. So here uh, the condition is given that m is less than, so we can say that rank of our, our given matrix is must be less than m. Okay. Uh, the highest rank possible for this matrix is m. It cannot be more than m. It may be less than, but it not more than. Okay. So uh, option A is the correct one. Okay. Let's move to the question two. Okay. So here we have the equation in terms of x1, x2, and x3, and they are asking about the solution of this system. We have to find either this system of equation has a unique solution, no solution, or infinitely solution, or two solutions. So here first, let's form the augmented matrix. The coefficient, we have to write the coefficient of the corresponding variable. Here again 1 minus 1, here 0, here again 1 minus 1 and 1. Here we have to write the right hand side the same order 3, 0 and 1. Now we have to apply some row operation on this matrix and reduce it into echelon form so that we can find the values of our corresponding variable easily. Okay, so let's do some row operation. First of all, let's subtract r1 from r2. It's become our new r2, and let's subtract r3, sorry, r1 from r3. It's give new r3. Okay, so after applying these two equation, so two operation, we get the matrix like first row is remain as it is 1 1 1. Here 3 is remain as it is. The second row will change because we have applied operation on row 2. So here we have to subtract first row from the second row. So here 1 minus 1, here 0, here minus 1 minus 1 minus 2, here 0 minus 1 minus 1, here 1 minus 1 0, 1 minus 1 minus 2, 1 minus 1 0. Sorry, here 0 minus 3, then minus 3, here 1 minus 3 minus 2. Now sorry, this minus 2. So this matrix is still not in the ready equivalent form, so we have to apply one more operation to bring it in the form of equivalent form. So what we are applying next is, let's subtract r2 from r3 and it's become our new r3. So after that, after this operation, what we are getting is, first row is remain as it is 1 1 1. The second row is remain as it is. The third row will change because we have to subtract this R2 from R3. So here minus 2 minus minus 2, it's become plus 2. Here minus 2 already. So we get 0. Here 0 minus minus 1, it's become 1. Here minus 2, and here we have 2. Sorry, minus minus 3 is become plus 3, and here minus 2 is already. So we get sum is 1. Okay. Now what we are going to do next is just back substitute our this coefficient into this equation. So here this third row we have to start from the third row. So here this represent 1. It's mean here is the x3 variable. So x3's coefficient is 1. On the right hand side we have 1. So from that we can get x3 is equal to 1. Now the similar way, if we go from the second row, then what we get minus 2x2 and minus x3 is equal to minus 3. But we know x3 already, so let's put it here. It's minus 1. It's become plus when go to this side, and it's minus 2. Okay, then x2 is again 1. Now, from the first row of this reduced matrix, we get x1, x2, x3 is equal to 3. Now, we know the x2 and x3 and x2 both put here and solve for x1. So, we get x1 is equal to 1. So, what it means? We are getting the unique solution for all three variables x1, x2 and x3. This means these three systems have a unique solution, and which is correspond to 1 1 1. Okay, so system has unique solution. Option A is the correct answer. Okay, let's move to the question number 3. Question number 3 says the eigenvalues of the matrix. Okay, they are asking about eigenvalues. So what we are going to do is first of all form the characteristics equation of this matrix and uh, solve for values of lambda. From that we get the eigenvalues. So here let's here our matrix A is 0 minus lambda, 1 as it is, here 1 as it is, here 0 minus lambda. Okay, we have to find the determinant of this matrix and equate is equal to 0. So let's form determinant. It's minus lambda, it's 1, 1 minus lambda. Take the determinant and equate is equal to 0. So here what we get is lambda square minus 1 is equal to 0. So lambda square is equal to 1. If we solve for the lambda, then we get the values is equal to plus or minus 1. Okay, so that's it. We have done. Here the value plus 1 and minus 1 represent the eigenvalue of this matrix. So option D is the correct eigenvalue. Let's move to the question number 4. Okay. Question 4 says the eigenvalues of the matrix. Okay. And here again they are asking eigenvalues this matrix, but here the matrix is 4 cross 4. If we go with the same procedure that we did in the last example, it is become short and consuming. So we are going from the shortcut method in case of MCQ. So we are simply going to use the properties of eigen values. Okay, here typically we need only two for this example, but uh, eigenvalue have lots of properties that must be known for you. Okay, so let's write some first property. It says that sum of all eigenvalues is equal to trace of this matrix. Its first property, and second property of this eigenvalue is the multiplication of all eigenvalues gives the determinant of this matrix. So okay, here the what is the trace? It is nothing but the sum of these leading diagonal elements. You have to edit this four value. It's represent trace of this matrix. So let's write here trace of this matrix. Let's say matrix M is equal to 2 plus 3 5 minus 2 3 plus 4 is equal to 7. So we are getting trace of this matrix is 7. Now we have to find the determinant of this matrix. But here again it's 4 cross 4. So we have to decompose it into 3 cross 3 matrix. We can resolve it about any rows or column whatever you like, but here the I am doing about this first row because it is easier than other comparison to the other any rows. Okay, so here we have to write first this element, first element of this matrix 2 as it is. Now we have to delete this first row which corresponding to the, sorry, first column which corresponding to this element, and this rows which corresponding to these elements. Okay, so we have to delete this first row and first column. Whatever may be remaining we have to write here in as it is 3 0 sorry 3 0 0 0 minus 2 0. Okay, 0 minus 1 and 4. Okay, the second element of this equation is this, here is minus 1. We have to put minus 1 here, sorry minus here, because we have to take the minus 1 is to I plus j, where I and j is the index of these elements. So here I is 2 and j is 1, so we get minus 1 to the 3 which is minus 1. So we have to put the minus sign in front of this second term. So here minus sign from this, and this minus 1 is from this matrix. So the remaining we have to delete this first row and this second column because minus 1 is corresponding to next column. So the remaining 3 cross 3 is 0 0 0 0 minus 2 0 0 minus 1 4. Okay, now again we have to put plus here 0, and if you delete this first row and this column, so we get 3 cross 3, but here it's already 0, so it not make any difference whatever it may be. In fourth element is also 0, so it again whatever we get it's must be 0. So here the whole column is 0 0 0. So we know that the determinant of this matrix is 0. So this term is also 0. So we end up with only this first, and we have to solve this only 3 cross 3 determinant. So 2 as it is, let's solve it, and 3 as it is, and multiply minus 8 minus 0. Now the everything remaining is 0 because these two elements are 0. This element is 0, this 0. So we get here also 0. So after simplifying we get determinant is 6 multiplied by minus 8 which is minus 48. Okay, we have solved determinant of this matrix is minus 48. Now check one by one four option, and let's first of all sum these four values, and what we get is 0. Okay, so option A is not correct according to this property. Option B, we get sum is equal to 7, and the multiplication of this four value is 6 multiplied by minus 8. Okay, again minus 48. So let's check option B satisfy both this condition, but let's check options, also check the option C. The sum is 10. No, it's not satisfying. The option C is not correct one. So directly option B is the correct one. Okay, so let's move to the fifth problem. Okay, in the fifth problem, sorry, it's in 9. Okay. So fifth problem says we have given matrix 2 cross 2 matrix and they are asking about the eigenvector. Okay. This time they are asking about eigenvectors, not eigenvalue. So what we are going to do in this types of MCQ, we are going from option one by one. So first, if uh, that any matrix A, it has uh, x, if it is an eigenvector, if it's an eigenvector, then in the output after multiplication, what we get is a lambda time the same vector. Whatever maybe vector is there, we get the same vector in the output, but with some scalar multiply by multiple of this vector. Okay. So here, what we are going to do is that write the matrix as it is minus 4, 2, 4, 3. Let's check first option A. What we get 3. Let's do the multiplication here. Minus 12 plus, okay, we get minus 8 here. 4 multiplied by 3, 12 plus 6, 18. So if you try to find out the lambda such that it's equal to becomes, after taking lambda out, it must be here the same vector as it is, as it here 3 into 2. So if you compare this element and this element, from that you can find the lambda, but this, from this equation, this second element and first element, we get the different lambda, so we cannot find any such lambda, any lambda. Okay. For that we can take out from this and we get the same vector. So option A is the not correct. Now check the option B. It's minus 4, 2, 4, 3. Let's multiply by this vector 4, 3. In the output, what we get? Let's do the multiplication. Minus 16 plus 6 minus 10. Okay, plus 60 plus 925. Again, do the same procedure. Try to find such lambda. So here again, we cannot find any such lambda such that we can write this matrix in the form of lambda multiplied by this, sorry, here 4 cross 3, not 4 4 3. Okay, this vector we have to write here as it is. Okay. So option B is not correct one. Let's see, check option C. It's minus 4, it's 2, it's 4 comma 3. Then the option C we have vector. Let's do the multiplication. What we get? Minus 8, minus 2, minus 10. Here 4 multiplied by 2 plus 8 uh, plus plus 8 minus 3, 5. So let's try to find out lambda such that in output we have this matrix multiplied by this lambda. So here you can see, you can take minus 5 out from this and you get this vector as same as it is here prior to multiplication. So let's take minus 5 out from this vector. So what we get? Minus 5, 2 into minus 1. Now you can see this vector and this vector are both same. So you can say that this is the our eigenvector corresponding to eigenvalue 5. Okay, it's, sorry, minus 5. It's minus 5 represent the eigenvalues corresponding to these vectors. So we can say option C is the correct answer. Okay, let's move to problem 6. Problem 6 says let A, we have to given A and we also have given A inverse and they are find, and in terms of there are A and B are the variable and they are asking about the sum of this variable. So what we are going to do is just multiply a and a inverse. In output, what we get is identity matrix. So we have given both a and a inverse in the problem already. So let's do the multiplication here. We can write this decimal in the form of this fraction. Okay, here is 0, here is 3. Let's multiply this a inverse. It's 1 by 2, it's 1, it's 0, and b is equal to, we have identity matrix, same dimension. So let's do the multiplication of this both matrices. So here what we get is uh, 1 first row and first column of this matrix. So here what we are getting is um, 1 plus its second element becomes 0. The second element of this new matrix is 2a minus b by 10. The same way, here is 0 and here, okay, 0. Fourth element is only 3b. Close the matrix and equate is equal to identity matrix. Now here in equal to equal sign, so we have compared the corresponding element of both the matrix on left hand side and right hand side, and we can solve for the variable a and b. So from this element and this element, we can say that 2a minus b by 10 is equal to 0. So a is equal to b by 20, and from the this element and this element we get db is equal to 1. So b is equal to again 1 by 3. So let's put this b here, and the values of a, it's 1 by 60. Let's sum of let's sum up. So what we get is that 2 below. So let's give 1 by 60 plus 1 by 3. Let's multiply by 20 here and 20 here. So what we get is 20 plus 20, 1 by 60. So we can take 3 out and cancel each other. 3 3. So we get 7 by 20. So the option is the correct one. Okay, let's move to the problem 7. Okay, the problem 7 says the rank of the matrix. Okay, they are asking about the rank. So we have to reduce this matrix into echelon form. 1 1 1 1 minus 1 0 1 1 1. Okay, so let's do some row operation. So we have to r2 minus r1 becomes our new r2, and r3 minus r1 become our new r3. Let's write the matrix. What we get after this operation is, first row is remain as it is, 1 1 1. The second row, 1 minus 1 0 1 minus 1 minus, sorry, minus 1 minus 1 minus 2. Here again minus 1. Here 1 minus, okay. These both rows are identical, so we simply write 0 0. So now we cannot perform any other operation such that we can reduce this second row in also the form of a third row, 0 0 0, because they are linearly independent. So we can say that the rank of our given matrix is 2. Okay, because there is a two rows which are linearly independent. Okay, we have to not count this third row which is null space 0 0 0. So the rank of this matrix is 2. Okay, let's move to the problem 8. Okay. Problem 8 says the eigenvalues and corresponding eigenvector of the two cross 2 matrix are given by, okay, the eigenvalues and corresponding eigenvectors are given, and we have to find the matrix. Okay, so we are going by this property we have used in the previous example. It is ax is equal to lambda into x. If we multiply any vector by its eigenvector, then in output we get the same eigenvector that is here, and but here some multiply it by some scalar and which correspond to the eigenvalue. Okay, so what we are going in this problem also, we are going by the option. So let's check first option A. Option A has a matrix 6 6 2 2 6. Okay, and it has eigenvector. You can choose any one from these two. Let's take first. So after multiplication, what you get is 6. Okay, 8. Here again 8. So you can see that I can take 8 out common and I get 1 1 1, which is the same as here. These both are exactly same. So we can say that this 1 1 is the correct eigenvector for this matrix. Let's check also this 1 minus 1. So 2 6 here 1 eigenvector. Let's do the multiplication. What we get is 4 minus 4. You can again take out 4 and you can see you can get the same vector which is here that you multiply with this matrix. So these both vector are the same. So we can say that the eigenvalue is 8 and the eigenvector is what, this one. If the eigenvalue is 4, then eigenvector is this one for this matrix. So option A satisfying uh, this condition. So option B is the correct one. But let's check option B. It must not satisfy this condition. Otherwise, two options are the correct. Let's use the first eigenvector. Let's do the multiplication. You can get the 10 and 10. You can still take 10 out and 1 1. Okay. Here also you get the same vector, same eigenvector. But here notice that the eigenvalue corresponding this eigenvector is 10. So we have not 10 as an eigenvalue in the problem. We have eigenvalue 8 and 4. So 10 is the not eigenvalue that given in the question. So option B is the wrong. Let's say option C. It is also wrong, but I'm checking for just. Let's 1 1. Let's do the multiplication. What we get is 12. Here also 12. You can get 12 out and you get 1 1. Notice here you also get the same vector, but here the eigenvalue corresponding to this vector is 12. Again 12 is not given in the question. Option C is also wrong. Similarly option C is also wrong. So option A is the correct one. So let's move to the problem number 9. The problem 9 says that for the matrix, okay, 2 cross 2 matrix is given. The eigen values corresponding to the eigenvalue. Okay, they are asking about the eigenvalues. So same procedure, same concept. We have to write the vector here. It is given that it is already an eigenvector. So let's multiply this matrix with the eigenvector. In the output, what we get after multiplication? Let's write here 404 plus 202. Here also 202 plus 404. Sorry, 404. Okay, you get 606. 606. Now you can see if you take 6 out from this vector, you ought to get 0. Now see this vector and this vector, that is we have multiply with this vector, this matrix are both identical. So we can say that uh, 1 0 1 1 0 1, it's the eigenvector of this matrix and it's corresponding to the eigenvalue 6, because whatever its scalar is here, it's represent the eigenvalues according to this property. Ax is equal to lambda into x. Okay, this is the basic definition of this eigenvalues and eigenvector. So option A is the correct one. Let's move to the problem 10. Okay, I think problem 10 is not there. So that's it. Okay, thank you for watching.